On questions 40 through 43, they're going to ask us to use the quadratic formula in some respect, and so that's what we'll do on these 5 problems. So the first thing to do is always make sure it's set equal to 0, and you don't see even an equal sign here, so you don't have to worry about that. And so what we'll do is we'll call this term the a term. The first number's a in front of x squared. Make sure it's in front of the x squared term. B is the term in front of x, and c is the constant. And so we're going to end up using this formula, and I'll write it out here for you. Negative b plus or minus the square root of b squared minus 4ac. This is all over 2a. And so we'll go ahead and substitute these numbers in there. Here we have the opposite of b is going to be negative 5 plus or minus the square root of 5 being squared minus 4. It's always a minus 4 times a, which is 3, c is 2. This is all over 2a, so 2 times by 3. So we go ahead and do some work underneath the radical sign there. Negative 5 plus or minus the square root. We have 25 is what we get when we square the 5. Minus, because there's only one negative here. And 4 and 3 make 12 times 2 makes 24. So this is all over 6. And so here we're able to do some work. We've got the 25 minus 24 makes 1. So negative 5 plus or minus the square root of 1 over 6. Well, the square root of 1 is just 1. And so we can set up two problems. Negative 5 plus 1 over 6. And we also have the negative 5 minus 1 all over 6. And so when we do some work there, negative 4 6 makes negative 2/3. And then the last part here would be negative 6 6, which makes negative 1. So those are our two x-intercepts. The next one, we've already got it set equal to 0, so we're going to pull out our a term, which is 1. B is negative 4, c is 8. So we go ahead and substitute those numbers in there. It's going to be opposite of b, so 4 plus or minus the square root of negative 4 being squared, minus 4 times a, which is 1, c is 8, and it's all over 2 times by a, which is 1. So 4 plus or minus the square root of 16, and then we have a negative, and it's a negative 32. And so we got a problem here, because when we go ahead and do that subtraction, we end up with a negative number. And so we end up with 4 plus or minus the square root of negative 16 all over 2. And there's our problem. So I'll highlight it right here. When we have this negative sign underneath the radical, that means we're going to end up with no solutions, no x-intercepts. Over here, what I would end up doing is moving this 4x over and the negative 1 over. I would do that. I would always solve for 0, or set it equal to 0, but I always want to have the x squared term as positive. And the reason is that if it doesn't work out quite right, where it doesn't come up with radical roots, you'll see the answer when the x squared term is positive. Otherwise, it'll look a little bit different. And so here's our a, our b, and our c term. And so I go ahead and substitute those numbers in there. Get rid of that. And we end up with this, a 4 plus or minus the square root of negative 4 being squared minus 4 times 2 times by negative 1. And it's all over 2 times by 2. So we end up doing some work underneath that radical sign. 4 plus or minus the square root, and we now have 16. And this is going to be a plus 8 this time because of the two negatives. Notice we have two negatives here, make a positive 8. This is all over 4. So when we go ahead and do some work there, 4 plus or minus the square root of 24 over 4. And that would be the answer that you'd end up seeing on the test. So here we go ahead and move this 3x over, and I'll move the 2. So I'm doing opposite operations, and we end up with a 5x squared minus a 3x minus a 2 all equals 0. And then I'm going to go ahead and use the quadratic formula, so opposite of b plus or minus the negative 3 being squared minus 4 times a, which is 5, c is negative 2. It's all over 2 times by 5. Do some work there, 3 plus or minus the square root, and we end up with a 9, and this is a plus sign this time. 9 plus, this makes 40. And when I go ahead and multiply all those numbers together, it's all over 10. So it's going to be a perfect square. 3 plus or minus the square root of 49, which is 7. and it's all over 10. So we can rewrite that as 3 plus 7 over 10, and we have 3 minus 7 over 10. And so when we go ahead and do some work, 10 over 10 makes 1. That's what this one is. This makes a negative 4 over 10, which will reduce down to negative 2/5. That's how they get those two answers. Over here, I'll add the 1 to both sides. So I get x squared plus 2x plus 1 all equals 0. So again, I'm using that quadratic formula because that's what they're saying to do here. And we end up with a negative 2 plus or minus the square root. And then we end up with a 2 being squared minus 4. So it's a minus 4 times a, which is 1, c is 1. And it's all over 2 times 1. So when we do the work here, we end up with a negative 2 plus or minus the square root of 4 minus 4. Well, 4 minus 4 makes 0. And so we're only going to end up with one root here because we end up with this canceling out. So we only have the one answer. So on some of these problems that I say use the quadratic formula, some of them are going to ask us just how many roots we have. So if you get a negative number underneath the radical sign, there's no roots. Positive number underneath the radical sign, there are 2 roots. And if you get a 0 underneath the radical sign, there's only 1 root, kind of like this last one. Well, on this one here, asking us to graph, what we do for graphing is always look at the y-intercept. Make sure your y-intercept is on there, and then also notice that this one ends up opening down. So it opens down. And so if this were positive, it would open up. But the a term being negative means it opens down. So I use that axis of symmetry first, negative b over 2a. And so I end up with a negative 6 over 2 times by negative 1, which just makes a negative 6 over negative 2, which makes 3. So we take that 3, substitute it back in for these x's, and find y. The tough thing to remember is it's negative 1 times by 3 being squared. So we got to square first in this case. And then times 6 times 3 minus the 5. So we end up with a negative 9 plus 18 minus 5. So 9 minus 5 makes 4. So there's our point, our vertex, 3, 4. That's where we're going to start this graph. So over 3, 1, 2, 3, up 1, 2, 3, 4. That's where we start. And then from there we just look at the parent graph. It's a y equals negative 1 times by x squared. So when you square 1, you times by 1, or negative 1, you get negative 1. So over 1, down 1 space. Over 2 spaces, though, you square that, you times by negative 1, you go down 4. So over 2, down 4 spaces puts us right, looks like here, and here. And that's what our graph would end up looking like. So it's an upside-down parabola. And really, if you get those things right, you get the upside-down parabola, you've got a good understanding about what it looks like. It might go a little quicker. When there's no b term, like this one, your x value is going to end up being 0. So we see a negative b, there's no b term, so it's 0 over 2 times by 2. So 0 over 4 makes 0. So you substitute 0 back in for x, y is going to equal the constant. See, 2 times by 0 squared minus 5 gives us negative 5. So 0, negative 5, that's where this thing's going to start. It's the vertex, 1, 2, 3, 4, 5. Down 5 spaces, use the parent graph. Parent graph's a little different. 2 times by x squared this time. So when you square 1 times by 2, you go up 2 spaces. So over 1 up 2. And then if you go over 2 spaces, you square that, you get 4 times by 2 gives us up 8. So over 2 up 8 spaces, put us here and here. And then you go ahead and draw the graph. Notice that this one opens up because it's a positive x squared. So opens up. Well, taking a look at that next one here, we've got a negative x squared, so I know this opens down, so I'll start by finding that axis of symmetry. It's the opposite of b, so 4 over 2 times negative 1, which makes negative 2. Substitute those numbers back in there. Y equals negative 1 times by negative 2 squared minus 4 times by negative 2 and a plus 1. So this makes negative 2 plus, and let's see, actually this should be a 4. Negative 4, because I forgot to square the 2. So 4 times by negative 1 makes negative 4, plus 8 plus 1. This makes 4 plus 1 makes 5. So y is 5 when x is negative 2. So that's the vertex, negative 2 comma 5. That's where I'm going to start. So over 2 spaces to the left, up 5, 1, 2, 3, 4, 5, and then just follow what the parent graph said. It's the same parent graph we had over here. So over 1, down 1, over 2, down 4. So it puts a point there and there. And that y-intercept matches what the graph says. If you set the x is equal to 0, we end up with a y-intercept of 1 right there. Well, the last one here, again, there's no x terms and no b terms. So our vertex is going to have 0 as the y. So 0 over 2 times by 1 makes 0. You plug that back in, you got 0 squared minus 4, y is negative 4. So down 4, 1, 2, 3, 4. This time the parent graph is just a y equals x squared. So when you square 1, you get 1. When you square 2, you get 4. So this means you're going up. Over 1, up 1. Over 2, up 4 spaces, here and here. That matches what the x-intercepts are. If I was to factor this, I would get 2 and negative 2. That matches. So those are problems you'll see on questions 40 through 45.